Hi, today I would like to take a look with you at an article that Marcus Walter wrote, and in general, if you are interested in domain-specific languages and you do not follow Marcus Walter, do yourself a favor and start doing that. So let's see if I'm able to share the screen. So you will find this content on LinkedIn. Just look for Marcus Walter and you will find this article published recently. I think it's super interesting. We will not go through all the details, but I'm sharing it with you so you can take a look for yourself. And in the description, you should also find the link. But yeah, of course, Marcus starts by sharing his experience and explaining how many different applications there are of software in the health fields, starting from medical companion software, so application that you run on your phone, and I think it tackles that here. But it also mentioned drug trials, for which there is typically some supporting software, but also psychological assessments that are typically administered to questionnaires that are can be automatized. So there are a lot of different situations in which you want to use software to support the health sector. So in essence, getting digital therapeutics. And of course, you want these to be scientifically rigorous, to be validated by experts, and to be applied consistently based on the indication of the experts, right? You don't want software engineers to misinterpret requirements and administer a treatment that is not appropriate. And one ingredient, we will not look at all the 12 ingredients, but the first one we need to take a look because it's about DSL. And you can read it for yourself, but my understanding is that through DSL, basically, we can ensure that we capture the intention that the medical expert had in a way that is very precise, so there is no space for misunderstanding and can be in some way executed. So by expressing these requirements through a domain-specific language, we can do that to a level of precision so that we can generate code or interpret these DSL and execute it. There is not someone looking at this, interpreting, and adding his own interpretation and the consequence space for error. So we can avoid that using a DSL. Second point, also very important, so tracking the connection between a certain piece of the DSL and the corresponding requirements that originated this piece of code, so that we can verify that the code is based on the requirements, so there is a traceback, but we can also notice when we change our requirements, we can know which elements were derived from that requirement so that we can go and reassess that code and possibly adapt it to the change requirement. Then we have simulation and testing. So, when you write your requirements on a Word document, the only way to verify that is to think really, really hard if you can think of an issue with that series of requirements. And guess what? Doesn't work. Doesn't work for any set of requirements that is not trivial. But if you express this condition through a DSL, then you can run simulations, you can run tests, and so you can consistently verify if there are mistakes. Then there are other 9 points that are inspired from the practices that are common in software engineering, but they are typically not common for the health sector. So it can be interesting to take a look. I will skip that, but I cannot skip the part in which Marcus explained or answer the question that everybody in these times will be asking, so why not using AI? And again, you can go directly at the source and read better than read directly what Marcus wrote instead of relying on my understanding or interpretation. But basically, AI is typically mostly correct, but it's not 100% guaranteed to be correct. So a 90% level of correctness is not really enough, right? So that already means that you may want to not generate your application using AI. You want instead to having an expert capture their ideas and express them formally and precisely through a DSL. In this sense, if even learning this DSL is too challenging, the person could potentially write something in a box and then an LLM read that prompt and generate the DSL code for them. And if the LLM generate the DSL code, then the experts can review it because it will be expressed in a language the expert can understand. It will be concise because the DSLs operate at a higher level of abstraction, and so it will be feasible to manually review that. While if the LLM was generating general purpose code, it will require someone with technical competencies, which is typically someone that has not medical competencies, and will be typically very bloated, complex, and will require a lot of effort to review. That said, once someone is familiar with the language, probably it's simpler just to write the DSLs than writing a prompt and then hoping the LLM interpret things correctly, and if not, going back and fix it. So yeah, I know that in a few minutes I didn't make justice to the complexity and richness and value of this document. So I invite you to take a look and in general to follow Marcus and learn from his amazing experience with domain-specific languages. So I was very happy to find this new article and I wanted to share it with you. Thank you. Bye.